This video is on testing transistors, and not only for function, but also to see what kind of transistor it is, whether it's a NPN or a PNP. So a couple of things you're going to need for this test. First of all, you're going to need a digital voltometer with a diode check on it, and you're going to need at least one transistor. I've got 7 transistors here, 3 different types. And we're going to see if they're all the same NPN or PNP or if there's different ones. So we're going to test them all here. The other thing that you're going to need is the handout that I made for you. And I know I've got my camera zoomed in a little bit, so I'm going to zoom out so that you can see the entire handout. So my experience has been it's really difficult to find any documentation that shows you how to identify a transistor. So when I ran across this, I made some copies, and I've put them in the module for testing transistors. So you can download them, you can print them off, you can hang on to a copy for yourself. But this covers a whole bunch of different types of transistors, and on the back side, there's also another little diagram that shows some of the more modern transistors that you run across. And so, for instance, we're going to be testing this style here, which is a TO220, and then there's a TO18 that we're going to be testing, and one that's similar to the TO92. But anyway, the reason you want to look at these is these handouts actually show you which of these terminals are the collector, emitter, and base. So again, that's this handout. Now the other handout that I've gotten for you is how to test a transistor. So, excuse me, this handout will actually walk you through the steps. There is a typo in this documentation though that you want to pay attention to, and that it says set the meter to ohm scale, and you actually want to set it to the diode scale, not the ohm scale. I think this document was actually written before we had meters that were commonly had the diode scale. If you try and test a transistor with the ohm scale, it will work, but I can tell you it's not as accurate. Sometimes you get misleading information or test results if you use the ohm scale. That's why, if you have it available to you, always use the diode scale. Now, if you remember back from our chapter discussions, the transistor is nothing more than a diode, which a diode has N material and P material that's sandwiched together with an anode and a cathode. And with a transistor, we're just adding on another element to it. So in this case, we have a P material, N material, and then we added on another P material. And that makes a transistor. The way the transistor works is you have your collector, you have your emitter, and you have your base. The arrow in the electrical diagram shows you the direction that the current flows. So the collector and the emitter, these two terminals, are the load carrying terminals. The B terminal, which stands for base, that is your switching terminal. So this piece right here does not provide contact for current until the base is turned on. So you have a high current load that comes in on the emitter, it goes to the base, and then it comes out on the collector. So as the electricity comes in on the emitter, it gets to the base, and if the base is not turned on, that's where it stops. If the base turns on, then that closes the circuit here and allows the electricity to go from the emitter through the base and out the collector. So what we're doing is we're testing for continuity between the emitter and the base and the collector and the base. And we're also testing for directional continuity. So if you remember, a diode is a one-way check valve. It allows electricity one direction, not the other. This is a symbol for a diode right here. And so the electricity comes through there, it follows the direction of the arrow. It'll pass through that wall right there in this direction, but if the electricity tries to come back this direction, it's blocked. And so that's kind of what's happening here, is you got a diode here and you have a diode here. And so you want to check it for continuity in one direction and not the other, and then in one direction and not the other. So that's what we're doing when we test a transistor. So it's not as difficult as it sounds. So I'm going to zoom the camera back in and we'll go ahead and test these. Okay. So we've got our transistors, and we've got 3 different types of transistors. So I'm going to lay them out in the different types. So there's our different types of transistors. And looking at our paper, we're going to determine which transistor, or where the collector, emitter, and base is. So we'll start up here with this style of transistor. And according to our paper, our base is going to be this terminal over here. So the one on the far left. The collector is in the middle, and the emitter is on the outside. So this is the base, the collector, the emitter. This is going to be the base, the collector, and the emitter. And this one here, base, collector, emitter. So those are our terminals on that style of transistor. This style of transistor, what we're going to, if you look at this style, I'm going to tip this one up so you can see the top end of it. So this one, see that little identification lug there? And then the 3 terminals are kind of offset. They're almost in kind of like a U shape or triangle shape or something like that. So if we look at this one, the base is going to be in the middle. And that's with our little indicator pointing up here towards the top. And so this is going to be the base. This one's going to be the collector over here, and this one's going to be the emitter over here. And it'll be the same on these other 2 as well. Now this one, if you can see this one here, it's kind of a half round. It's not completely round. And so if I lay this one down with the flat spot facing up, the base is going to be in the center, the collector is going to be on the outside, and the emitter is going to be on the other side. So that's how we identify the terminals on each one of the transistors. Now, what we're going to do is we're going to set our meter to the diode check. Okay, and your meter should read OL when you first set it up there, and then I always double check my leads and just touch them together and make sure that I've got good continuity in the leads. Okay, now what I'm going to do is I'm going to put one of my meter leads, and it doesn't really matter which one. We'll start with the N first. So put my black lead on the N terminal, or the base, sorry. So I'm going to put my black lead on the base. And if you notice, I'm on a non-conductive material here. So if you do this on a metal bench, if your terminals touch metal, then you'll get a reading, if false reading otherwise. So this is best done on, you just put a piece of paper or something underneath your diodes, or sorry, your transistors, or something of that nature, and you'll be fine. So I've got my negative lead on the base, and I'm going to check for continuity on the collector, which I do have continuity, and I'm going to check for continuity on the emitter, which I do have continuity. So that part's okay. So I've got continuity between my collector and base and my emitter and the base. Now I'm going to switch my meter leads, and I'm going to put the positive on my base, and I'm going to check for continuity on my collector and on my emitter. And I should have no continuity, which is exactly what I have. My meter is reading OL when I check it from the base to the collector and from the base to the emitter. So because I have continuity when my negative is on the base, and I have continuity here, so check it here, I've got continuity that way, and I've got continuity this way. Negative is on the base, so my base is a N. So if I look at my transistor, If my base is an N, then P is on either side. So this is a PNP. Okay? So that transistor right there is a PNP transistor, and it's a good transistor. So there's nothing wrong with that transistor. So I'm going to quickly check the others and see if they're the same, which I believe they all are, but I'm going to double check and just make sure. So I'm going to put my positive meter lead on the base, check my collector, check my emitter. That's no continuity. Then I'm going to switch my meter leads. So now I'm going to put my base or my black on my base and check my collector, check my emitter. So because my black is on my base, that's a PNP. I'm going to do the same thing over here. Now if you see these two terminals here might be touching, so I'm going to move those out just a little bit so that I want to make sure that those terminals don't touch. So I'm going to try the same thing here. So my black is on the base, collector, emitter, and I have continuity on both. So now I'm going to switch my meter leads, and I'm going to check my red meter lead is going to be on my base, collector, emitter, no continuity on either one. So this right here is a PNP, and it's a good transistor. So I've checked all three of these. They're all PNP transistors, and they're all good. So I'm going to set them up out of the way. Now I'm going to check these other three and see what they are. Now if you remember on these, we looked at these, and the base is in the center. So this right here is going to be the base. Now I usually like to just lay the transistor down, and then I'll just trap I'm going to set these kind of off to the side for a minute. And so this terminal right here is going to be my base, and so I'm just going to trap that underneath my meter lead. Right there. So I've got it trapped under my meter lead, and then I can just touch my other terminals with my other meter leads. So no continuity, no continuity. So I'm going to switch my meter leads. So now I've got my positive is on my base, and I've got continuity on my collector, and I've got continuity on my emitter. So this is an NPN. Because my positive's on my base, I've got continuity between the collector and emitter. So that is an NPN transistor, and it is a functional transistor. So that one's good, NPN. So this one here, we'll try the same thing. So my center terminal, if I can, I'm going to spread these terminals out a little bit so that it's easier to get a hold of them. So my center terminal is my base, and collector, emitter, no continuity. So I'll switch my meter leads, put my black terminal on my base, collector, emitter. I've got continuity on both terminals with my black on my base. So this is a PNP, and it is functional. One last one here. So I'm going to do the same thing. I'm going to put my meter lead right there on my base. I've got continuity on my collector, got continuity on my emitter, and I'm going to switch my meter leads. Now you see there I've got that terminal was touching my meter lead, so I want to make sure that that does not touch the meter lead while I'm testing it, because that'll give me a false. Okay, so I've got no continuity there. So this is a PNP transistor, and it is functional. Last one. Okay, this last one, the center terminal is going to be my base. So I'm going to start with the negative, or with the positive. So I'm going to put the positive on the center one here, and I've got continuity there, and I've got continuity there. So right now this is telling me this is an NPN because my positive terminal is on my base, and I'm going to switch my meter leads just to make sure that everything is cool, and check it. No continuity, no continuity. So this is be an NPN, and it is functional. So that's all there is to testing a transistor. And the only reason that I'm having you do this, to be honest with you, is so that you can kind of understand how a transistor works and the relationship between the collector, emitter, and the base. So we'll see you in the next video.